Hajime Sugiyama from Mitsubishi Electric, and I'm an industrial IoT evangelist. Today, as part of my latest industry IoT trends for everybody, I'd like to talk about AI applied to robots. Lots of mega trends in the industries today: mass customization, time to market, cost reduction. A lot of people think that robots are the answer. So if I can use robots, I'll be able to solve these problems. But robot installation is not as easy as think. Installing a robot is just not set the robot and it works. You have to do a lot of things like adjust the gripper, vision sensor confirmation, positioning, simulation, and you also have to worry about the movement test. It's just not moving the hand, you have to make sure the arm doesn't get stuck somewhere. There's also some key points to think. Okay, then let's use AI to make it easier to install robots. But this AI, it has to be easy to use. Don't forget that there's a lot of people in the factory that have no knowledge about AI and data analysis and simulation. So this AI has to be easy to use, and this AI has to be close to the floor, meaning this AI has to respond quickly if something happens on the factory floor. When talking about AI in manufacturing, this is the perfect AI. A robot vacuum cleaner. I use this example because it's very simple. Just press a button and it works on its own. There is no knowledge you need to do it. The only knowledge is just pressing a button, and a vacuum cleaner my grandmother can use. So I think this is what the ideal AI, perfect AI should be. Something that's easy to use and something you don't have to program. Something that's already there and you don't have to think about it. When people talk about AI in manufacturing or AI in a factory, some people think there's going to be this kind of center AI, center controlled AI in a big server room that's communicating with all the devices on the factory, and if something happens, then the AI says, okay, stop this motor, move this robot over there, move this AGV over there, and it's central controlled. But this is not going to be the reality, and I think there's going to be an AI on every level, on the cloud level, plant level, line level, machine level, like a robot, and even on a component level, like a motor. Why I'm saying this? It's because of the reaction time. If you communicate the cloud, there's always going to be a time lag because they have to think over here and then give you a response. And maybe 5G will solve that problem, but then it's going to be a lot of cost in order to connect all your devices to the cloud. So this is a huge cost you have. So imagine the server and network costs related. Also think about safety and security. What happens if somebody trips over a line? Then your whole network is down because you're relying on this single cloud. It's not really realistic to do it this way. So I think in the future, AI is going to exist on all levels. And that's why Mitsubishi Electric, we're trying to develop AI which is close to the components, close to the robots. And in order to do this, we're reducing the number of calculations so we can reduce the memory space necessary for AI. And that's a key component of the Mitsubishi Electric AI create state-of-the-art technology. We call it MyStart, in our products. Using this compact die, we think there's a lot of things we can do with robotics to make it more easy to install, like reporting, predictive maintenance, and also calculating the optimal way that a robot should move. Let's go through some examples of how you use AI in robotics. One thing you shouldn't forget about manufacturing is that time is money, and that every millisecond counts. And I was in the factory, so I remember the days that I was in a production line counting how much seconds it makes to a product. Of course, AI can do a lot of things. It can teach a robot to move this way and this way, but it's not good enough if it's a slow movement because it's speed. A robot has to move fast in order to make it count in manufacturing. I mean, if it's a slow robot, it probably makes sense doing it with a human being. If you're going to be able to use that time and reduce the lead time, you're going to be able to save costs. So using robots is good, but it has to be fast. I want to use this example to understand, utilize how you should use AI in robotics. And we're going to use a simple application like bearing insertion, where we're putting this bearing into a hole. It looks like a very simple movement, I think you see. But it's actually not that easy. Okay? If you do it slow, it's easy. But what happens if you try to insert it very fast? If you do it fast, the mechanics are starting to vibrate, and then it's going to hit the edge of the hole, and it's not going to be able to put the bearing correctly in the hole, or you're going to damage the bearing itself right now. So that's why it's so important to find the optimal speed that you can insert this bearing into a hole. And that takes a lot of adjustment time. To take it a step further, the most optimal movement, the most speed effective movement is going fast. When you get close to the hole, slow down so the vibration stops. Once you get into the hole, speed it up again, and then so you don't hit the bottom, slow it down again. So it's a movement that goes like this. Fast, slow, fast, slow. Again, fast, slow, fast, slow. This is the way you save money and you save time by doing this movement. And in the past, an engineer was actually programming the robot to do this movement, adjusting the robot. Oh, I went too fast, so maybe I should slow it down the next time. So he could save the seconds that he needed to improve the lead time and reduce costs. We wanted to solve this problem because it took a lot of time. And what we did was we utilized AI and also the force sensor that we had on a robot. What a force sensor is a sensor that feels force. Meaning, if it hits something, then it will feel, oh, there's pressure there, so I hit something. Maybe I went too fast. So it's kind of a combination of using this face sensor and AI to find the optimal movement. So what we did is we programmed the robot so it could find the fastest movement by itself. So we do a test movement, and if it was too fast, it vibrated, it would hit the robot hand, and the force sensor will feel it. So it'd say, okay, it's too fast. The robot will try again by itself. If it hit it, it's too fast. Okay, let's go slower. And if you do that over and over again, then eventually it will find the optimal best speediest movement without hitting the hole. And this is a self-learning process, you know. You can see the benefit over here, before and after. This is before AI learning, after AI learning. See the speed, it's very fast. It's not that we couldn't do this with programming. In the past, an engineer would sit by the machine and program to do this, but because we are using AI, this became a self-learning process. And you can see the beautiful self-optimization, also the reduction of setup time, because the robot human engineer didn't have to do the programming, all the programming by itself. And also we're not even using cloud because this is a kind of option included in the robot system. So these kind of AI technologies help install effective robots in the factory. The other difficult point about using robots in factories is vision systems. Can you tell which is the right egg with the correct egg and real egg and which is not the real egg? It's very difficult, and when I ask people, only about 50% get the right answer. In this case, the left is a picture and the right is the egg. What I want to say is that vision systems are very difficult to install. It's because if a human can't detect it, how can a robot vision system detect it? So that's the way the time we spent in adjusting the systems is sometimes very time consuming. This is a beautiful application you see in robotics today. It's called bin picking, where we place parts in a bin and we program it so a robot picks it up so it could insert it into a line. So you have hundreds of parts here, metal parts here. Why this is such a nice application is because traditionally for these kind of products, you usually use what we call feeder machines. You have a dedicated machine that feeds these parts into the production line. Problem is, when you change the product you're manufacturing, then you have to change the parts, so you end up spending time exchanging in the machine, exchanging the feeder. But if you have a robot that can do it, you don't have to change anything. You just have to press the button, and it will recognize the different part, the different shape, and pick it up yourself. So a lot of people say, okay, this is a good place to use the robot, let's use it. The problem is that installing this application takes time, and it needs a lot of experience, because experience is necessary, but also you need experience on two things. You need to know the vision system, and you need how to move a robot. That's why we're thinking, okay, can we use AI to make this process easier, to teach the machine how to do bin picking? The difficulty of bin picking is the adjustment of the vision system, because there's so many variations of how a part could end up in a bin. And the goal, the thing you wanted to find out in bin picking, is the kind of edge of a product. Because if you don't recognize the edge of it correctly, you don't know where to pick it up and how to position the gripper. So detecting the edge of the part you're going to pick up is very, very important, but that needs adjustment. What we did here was we did a lot of simulation on the various kind of ways that a part could fall into this randomly into this bin. And by using that, we were able to pre-adjust the vision system and pre-adjust the parameters, which made it easier when you put in the actual application to adjust the machine. By doing this pre-simulation, we'd be able to reduce the time necessary to set up the system to 5 hours to 1 or 2 hours. So imagine if you have 5 systems like this, you're basically saving 2 or 3 days by doing this. Another interesting, and I think this kind of application, self-adjusting applications, is going to become very, very important, because you see the factory of the future. All these robots moving around AGV, I mean, it's beautiful, there's no jigs necessary, but on the other hand, they're going to be necessary to be able to adjust by themselves, and that's where AI will become very, very handy. I'd like to talk about another application where AI and robots will be useful. For instance, in a logistics center. Logistics centers handle various parts, big parts, flat parts, round parts. And to do this one robot hand is difficult, because you have a gripper, but you can't use a gripper to suck up, hold a round ball. In that case, you need a vacuum type of hand. So you have to kind of decide what robot hand you're going to use to pick up things. Also important is to find the center of gravity, because if you don't pick up the right center of gravity, you're going to drop the part. And we thought, okay, can we use AI to make these kind of adjustments easier? You can see over here, first, by using real-time recognition, kind of find what part you're picking up, and then you can tell the robot in advance, should I use a gripper or should I use a vacuum cleaner? And you're also teaching him, okay, this is the point of gravity. By doing this, when a box comes along, you do the scanning, and then you can tell the AI, through the AI, to the robot, okay, use a gripper, use a vacuum cleaner. It's a tennis ball, so here's the center of gravity. And it makes things a lot easier. And this is what we did in our Amazon Robotics Challenge demo over here. So hopefully it will be useful for the future. Another interesting application, like the factory of the future, is predictive maintenance. And this is what we did with a joint project with IBM. The application is we're monitoring a robot through the edge and using AI to tell it when it breaks, when it's going to break. When it's going to break, we tell the factory worker, okay, here's when you should do the maintenance and here's how to do it. when they go to repair the machine, he put on the AR glasses, VR glasses, and then he can actually told how to repair the machine. Robot. Here's an example. Sorry, it's a little difficult to see the letters over here, but there's an error pops on the production line. Okay, and then if you go to the robot where it's click, where it has the alarm on it, and click it, then a kind of AI conversation starts. So you ask, okay, what's happened? And it tells you there's a wave abnormality on this robot. So I recommend maintenance. You ask, okay, what should I do? And it will give you some examples on a maintenance screen. Change the belt, put in more grease. So say you pick, okay, I think replacing the grease should be the best. Start, and it'll give you a list of parts that you need to do the repair and maintenance, like grease, of course. Then you say, okay, I want to apply grease, but do I have grease in stock? Automatically, AI talks to the supply SCM system to find out if we have grease in stock. In this case, we don't have stock, so it asks you, do you want to order some? Yes, please order, because if I order now, I will get it tomorrow. Now it has all that information and said, okay, we've ordered it, wait for tomorrow, and then it gives you a recommendation of when you should do the maintenance, because you want to do it in a time where you're not in production, as you don't want to stop the regular production schedules. And then it's scheduled. When maintenance times comes, you go to the machine, you put on the AR glasses, so this is actually looking through the glasses. You do some movements with your fingers and goes directly into maintenance mode. Then, through the glasses, you can see exactly how you should repair the machine. Here's where you should remove the bolts, here's where you put the grease nipple, here's where you put in the grease, then take out the greases, put on the bolts, and then go back. So, very useful. In the past, you have to wait, you have to ask a person who has maintenance knowledge, or you have to bring a manual with you. But everything is done through AI, and it makes life more easier. And I'm really waiting for this kind of application to come to real life. Okay, I think that's the summary. Installing robots, AI in robots will become very important, but please be aware of the speed. If it doesn't work fast, it's not worth using it, that kind of AI technology. And also, I think you should select some AI that is invisible, that's already included in the robot, so you don't have to think about it. And that's what we're trying to do in Mitsubishi Electric, put a lot of cool AI technology into our robots. I hope you enjoyed it, and thank you very much, and see you again.